Just give it a couple minutes, see if we get any latecomers. All right, I'm gonna get started. So, 19.2 is electric force. All right, and we're just kind of trying to look at how much do opposites attract, how much do like particles repel, like what is the value of that repulsion or attraction, and how do we figure it out? Because we can figure it out, but how do we figure out what that number is or how big that force is? So vocabulary, we only have one real big vocabulary point for this section, and that is Coulomb's law, right? And Coulomb's law is what tells us how big the force between two electric particles is. So the force between two charges, right? Coulomb's law gives the force between two charges. The strength of the force depends on a couple different things, right? The size of the two charges, right? How big is the electric charge that we're talking about, right? The bigger the electric charges are, the more force we're going to have. The smaller the electric charges are, the smaller the force we're going to have. And how far apart they are. So if the charges are close together, we'll have a really big force. If the charges are far apart, we'll have a smaller force. So three things, right? Size of the first particle, how big is the charge on that particle, size of the charge on the second particle, how big is that charge, and then how far apart are the two charges. Something I want you to notice, right, is the absolute value signs. Hopefully you've learned in math class, right? Absolute value signs means we don't care whether the particles are positive or negative, right? Regardless of whether the particles are positive or particles are negative, the force will be the same, right? If we're talking positive versus negative, we could have an attractive force versus a repulsive force, but that doesn't matter in when we're talking about how big the force is. So Coulomb's law is the force, right, which is F, equals K. K is a constant value. It's always the same number. it's this 8.99 times 10 to the ninth. So that's always in there. It's always K, times the absolute value of Q1 times the absolute value of Q2. Q1 and Q2 are the size of the first charge, right? How many coulombs is the first charge? Q2 is how many coulombs is the second charge. You need two charges to have a force. Divided by R squared, R being the distance between the two charges. So Coulomb's law, F equals K times Q1 times Q2 divided by R squared. Which way does electric force go, right? Electric force, right, because it's a absolute value, right, it'll always return a positive answer, right? We'll always get positive forces. And it's up to us to kind of decide afterwards, right, after we solve for the force, whether that force is going to be to the right or to the left or up or down, kind of depending on whether it's going to be repulsive or attractive. So if it's repulsive, right, like in the first case here, maybe our force is down and to the left, right? Or if we're talking about Q2, the force is up and to the right. So you see how we solve, right? If we're talking about Q1 and Q2 both being positive, like in case A, we get a positive force, but then this force goes down to the left because we're talking about Q1. This force goes up to the right because we're talking about Q2. So we kind of just have to decide, right, after we solve for the force, which direction that force is going to go. Electric force acts along the line connecting the two charges. It's either attractive or repulsive. So case A, you get repulsive, B, you get attractive, C, you get repulsive. And if we're talking, right, if all these charges, all these Q1s and Q2s are the same size, they'll all have the same force, right? Q1 and Q2, regardless of the sign, will always have the same force, right? This force is equal to that force. This force is equal to that force. This force is equal to that force. We always get the same one. But then afterwards, right, we have to decide which way that force is going to act, right? Is it going to be repulsive and push away, or is it going to be attractive and pull towards? So our conceptual example here, right, a proton and an electron initially separated by a distance d, right, so they're d far apart, are released from rest simultaneously. The two particles are free to move. When they collide, are they at the midpoint of their initial separation, closer to the proton, or closer to the electron? So we've got two particles, right, proton and electron. We're going to release them. They're going to move towards each other, right, because electrons are negative, protons are positive, so they should attract, all right? Where will they end up, right? Will they end up closer to the electron over here? Will they end up smack in the middle? Or will they end up closer to the proton over here? And when we look at this, first thing we should do is compare the forces, right? How do the forces on these two compare? Well, the Coulomb's law equation says F equals K times Q1 times Q2 divided by their distance squared. So when we look at this, right, Q1 will be negative E, which we would make absolute value, so just E. Q2 is positive E, which if we take the absolute value is just E. So E times E divided by D squared. We look at this, the force on both of them is going to be the same, right? It's just going to be in opposite directions, right? That's another, like Newton's third law, right? The force, every force has an equal and opposite force. So if this electron is pulling on the proton with a force of F, then the proton is pulling on the electron with a force of F. These F's are the same size, right? One's positive because it's going to the right. One's negative because it's going to the left. But the forces are the same size. So now we want to determine how does that force affect the movement of the particle. So when we have a force F pulling on an electron, how does that compare to a force F pulling on a proton? Well, protons are way bigger than electrons. So if we take the same force and we pull on something small versus pulling on something big, which one's going to move more? Hopefully the smaller one moves more, right? So the electron, when we let these go and we let them move towards each other, the electron, because it's experiencing this force F, is going to move pretty fast to the left. The proton, because it's much more massive, even though it has the same force, will move slower, or sorry, did I say left? The electron moves to the right, proton's going to move slower to the left. So if the electron's moving fast and the proton's moving slow, where are they going to meet up? They should meet up closer to the proton. So if you read the reasoning down here, because of Newton's third law, the forces on the electron and the proton are equal in magnitude and opposite in direction. For this reason, it might seem that the particles meet at the midpoint. The masses are quite different. In fact, as mentioned in 19.1, the mass of the proton is 2,000 times greater than the mass of the electron. Therefore, the proton's acceleration or movement is 2,000 times less than the electron's movement. As a result, the particles collide near the position of the proton, right? More specifically, they collide at the location of the center of mass, which would be closer to the proton. So the answer here is the particles collide closer to the initial position of the proton. So the last part here is just conceptual questions, and I did a answer video to those already. That should be in the 19.2 folder, so you can check that out. Other than that, that was a really quick one, right? Nothing crazy. Just going through the electric force and how we can solve some problems regarding electric force. Your work today is 19.1 in the chapter 19 folder. 19.1, there are a couple of questions. I think there's like seven questions that are called 19.1 chapter problems or something like that. And there's a submission box for those. So the 19.1 chapter problems, submit those for me. Then 19.2, the 5 questions here at the end, 15, 16, 17, 18, 19, and 20. I guess that's 6 questions actually. All right, so 19.1, chapter review questions, submit those. 19.2, conceptual questions, submit those for me. There should be a video to the 19.2 chapter questions. There is not a solutions video for the 19.1 chapter problems. All right, let's stop that. Excellent.